same spot for all of them. And then you get down into, let's see, dot 80 or impacity. You can highlight these kind of on the page, so or circle them or something, so you kind of have a reference there. The one that's not on this one that you won't get to until you get into raceways is dot 20. Dot 20 is a minimum size conduit. So if you have a diameter, so if you have a raceway like EMT or rigid, you'll have in dot 20 a minimum or maximum size if there's maximum size. And then the dot 104 is your outer sheath or outer conductor sheath. And 116 is, excuse me, conductor minimum and maximum size and sheath. And then dot 116 is going to be your outer covering. So the neat thing about that is that if you're looking for, like I said, for MC bending radius on page 193, it's the same dot 24. So all you have to do is kind of get your head wrapped around that, and once you kind of understand how it's laid out, even the raceway types, you have all of your non-metallic first, and then all your metallic after that. And then even within your metallic and plastic groups, you have rigid and flexible. So it's a pretty logical thing. I know that flexible plastic tubing is going to be after rigid plastic tubing, which is going to be after other types of metal tubing. And so that's kind of a nice little outline to kind of keep in your head as far as Chapter 3 is concerned. And so looking at it from the standpoint of that, all you have to do is kind of get I don't know, I guess I said metals first, which is what comes in any category. So this could be this and this and this could all be kind of in the same category. So your conduits come first, though, and your tubing is coming at the back, which is why EMT is not in the same area as EMT and IMC, because both of those are conduits, and EMT being a tubing type, which is just a thin wall difference is really it. You're going to find definitions in that line item category 1 there. You're also going to find, the majority of those will come out of 100, which are just straight out. They'll give you a question and say, what's the defined term of da-da-da-da-da, right? The other place you can find them, though, is going to be in these dot 2s. And that, by the way, is the same all the way through the entire code book. That same dot 2 will apply just about throughout the whole code book. It's one of the only sections it does, so we wish they used the same common numbering system for a lot of stuff in their other chapters, but they don't. But the dot 2 is unique, has definitions, and you'll also find definitions buried as examples and questions. So I'll give you one that I promise you everybody in this room has either seen or will see, and if you haven't seen it, or if you have seen it, you may or may not have gotten it right, but excuse me, if you have seen it, you might not have gotten it right. It has to do with a generator, and they're giving you a building, and they're asking you right here where those conductors come underneath the building, and these conductors are fed from a generator on the back out here. And they tell you that this is within sight of the building, so you can see from here to here, and it's 55 feet. This generator's got a disconnecting means mounted where it's accessible, readily accessible, and it's integral to the ATS. So you got an ATS and a disconnect right here. And so this generator is not a bad picture, huh? All right, they're asking you, what do you have to have right here on the building where those conductors feed inside the structure? And normally you'd say a disconnect. But if you look in the back under 700, the exact article that they, if you spend enough time to try to find it and actually end up landing on it, if you look on page 625 at the very bottom left-hand column there, under number 6, it says outdoor generator sets, and it says real clearly there that as long as you have a disconnect that's located within the side of the building, which they give you that, they tell you it's within sight, there's nothing blocking your construction here. And then they're asking you, do you need a directory or a plaque? Do you need a knife switch? Meaning a disconnect type that doesn't have any overcurrent protection device in it, or an additional disconnect. And the other one is something that I can't remember off the top of my head, but it's something that sounds right. So it's one of those that you want to answer, but I can't remember what it is off the top of my head. But it tells you right here under number 6, you don't have to have an additional disconnecting means. And it's worded almost identical to the article on the question. So what would you pick out of the other two that your choices are? The black director, maybe?
Yeah.
I mean, there's a rule in chapter 100, excuse me, article 110, that requires you to have one. There's in 230, you can find one that has, where you've got different systems, you have to have a directory. So there's some places in the code book you kind of talk yourself into that directory, that black. The knife switch, you know, you'd be hard pressed to try to talk yourself into that because there's really not any connection to that in any emergency systems for sure. So really this is the controlling article, and I can tell you right now that the answer is you have to have an additional disconnect means. But the average test taker is not going to answer that because if you're looking at it, it tells you real clearly you don't have to have one. So what the heck? Well, it's not the word I'd use if I was going to test me. WTF, but anyway. Any clue? Talking about definitions here? Hint? Hint? No. All right, I'm going to let y'all stew on that one for a minute since that seems to be hopefully that'll maybe put y'all in Article 100 later and kind of dig around for the definition that might make that change, possibly. I'll need some coffee. But I buy a round of Red Bull. On page 29 in Article 100, I'm going to lead you by your short hairs. On page 29, the definition, the defined term of insight is what? How many feet? 50 feet. I can see just as clearly at 55 feet as I can from 50. It won't make a gnat's hair worth of bit of difference to me, because to me that's still within sight. I can physically see a lot further than 55 feet, right? But the defined term of it within the code is exactly 50 feet or less. So in that case, they kind of, yeah, exactly. So they can tell you that it's within sight, and there's nothing wrong with that. It's true, but as it's defined by the code, it's not within sight. So that's one of the ways that you've got to be careful with definitions, because they can change an answer just like that, and you wouldn't even notice it. It'd be really easy to answer that question and feel like you got it correct. Not easy, it's one of the harder ones to try to justify your answer in a different area, but you certainly would be easy to answer it if you could have understood what the definitions are. So my whole point of that is that there's a list of defined terms that I've given you on that articles to study, and then the one I'm going to print out here in just a minute or so when I get a chance has got a few more that are on that articles to study that she gave you yesterday, that list of cheat notes. Those are terms that at the bare minimum you need to understand what they are and kind of, not memorize them, but at least be really comfortably familiar with them. One of them that's on there is the guaranteed question. You'll have it on your test, I promise you, and that is, what's the minimum interrupting current rating for a multi-case circuit breaker? You remember that one? Like 5,000, 10,000, 20,000, 20, 15, something like that? Anybody have any idea what the minimum AIC rating for a breaker is? Anybody know what an AIC rating is? Interrupting current is one of those things that, if you look at a breaker, standard multi-case circuit breaker, we're talking about a device that has two types of protection in it. We're real comfortable and understand the thermal part of it real well. That stamp that's on the little handle, it says 20 or 15 or whatever, it's 200 amps, whatever, that's a thermal rating of that breaker. Meaning that the overload protection of that device is whatever that rating is. So if I had a 20 amp, if you're looking at a chart, this is an inverse time circuit breaker, and an inverse time circuit breaker just means that when the time goes this way, the current goes the other way. They're inversely related, right? So if the amperage goes up, then the time shortens. And that interrupting current rating is whatever that limit is of that circuit breaker to clear a fault event. Not a thermal event, but a fault event. So a thermal event is what that 20 amp rating is. So, 20 amps, I can run a breaker somewhere right at 19.9, or maybe right at 20 for a considerable amount of time. After about 3 hours or more, it's going to be enough heat on that conductor to probably eventually trip it. But it may happen over a long span of time. And, if you ever put on a breaker and it took a second or two and then finally tripped, and it was kind of a soft trip. Have you ever had that happen to you? That's a thermal protection, okay? When you turn one on and you feel like it was about to pop out of the panel at you and there's a big flash of fire underneath it, and that probably happened to everybody in this room at least once, and almost the first time it happens to you, you don't want to touch it again, you're afraid it's going to blow up, right? That's a magnetic fault or a short circuit, a ground fault, some event that has an inrush current that's sometimes in the tens of thousands of amps. And so your inrush current rating, your interrupting rating, is a number that's real high compared to your thermal rating. And it's just a magnetic part of the device that's designed to protect against a real large inrushing current that is, predicated or based on what the service has available to give you, okay? And on the journeyman's exam, they've got a real complicated print question. It has to do with the service transformers feeding a 4.5 total impedance, and then they're going to change them out to a 3.5 impedance value for a total Z for the service. And what do you have to do on your side to protect against that? Do you have to resize your wire? Do you have to put in a 250 amp breaker instead of the 225 that's there? Do you put in an 18K or a 9?